Hello everyone, welcome back to our channel. Today we are going to discuss about electric charges and fields previous year's problems. Look here, one problem they have given. A particle of mass is how much? 2 into 10 to the power of minus 6 kg with a charge of 5 into 10 to the power of minus 6 coulombs they have given. The question is where we are taking this one. See, hanging in air above a similarly charged conducting sphere. The charge density of the surface is, we have to find out the charge density of the surface. Anyway, here we should consider two surfaces. One is in air, another one is we are placing above on that. Then we should find out the charge density. So the given data is what? See, given data is, anyway we are using directly this formula. You know that intensity E equals to sigma by epsilon naught. Here sigma is the surface charge density and E is the intensity. What is the formula for E? E equals to F by Q and sigma by epsilon naught. So, but instead of F, it is hanging in the air, means we are taking instead of F mass into acceleration due to gravity. From the sigma equals to mg into epsilon naught by charge. Then you substitute all values. The given data is mass of the body is 2 into 10 to the power of minus 6 kgs. G value is 10 meter per second square. Epsilon naught value is 8.85 into 10 to the power of minus 12. Charge of this one is, they have given that 5 into 10 to the power of minus 6 coulombs. After simplification, you can get the answer. Sigma equals to 35.4 into 10 to the power of minus 12. But the unit is what? Coulomb per meter square. Coulomb per meter square. So, based on the given data, we can find out the surface charge density. E equals to sigma by epsilon naught. We should find out the sigma. But instead of F, they have given mass of the charged body. Mass into G we are using. Then we are going to the another problem. The problem is, look here, a thin metallic spherical shell of radius is how much? R, contains a charge Q on its surface. A point charge Q1 is placed at the center of the shell and another charge Q2 is placed outside the shell at a distance of x from the center. Then the forces on Q1 and Q2 respectively. The forces are Q1 and Q2 respectively. How to do this one? For this problem, we can go through the, first we should draw the diagram for this. What they have given? They have given two charges. One is the inside, another one is the outside. See, one spherical shell is there. Inside you can take charge is Q1 and outside you are taking Q2, and this charge is how much? Q, and the distance is x. Here clearly we can say that on the charge Q1, it is inside the conducting sphere. So inside intensity is 0, means here force on Q1 equals to 0. Force on Q1 equals to 0. But force on Q2 equals to, you can take it, F equals to this one, 1 by 4 pi epsilon naught Q2Q by x square plus 1 by 4 pi epsilon naught Q1Q2 by x square. Q1Q2 by x square. So take the common, 1 by 4 pi epsilon naught Q1 x square, 1 by x square, or x square also we are taking. So inside the bracket you are getting Q1 plus Q2 is also common. Q plus Q1. So this is the force acting on the Q2. Then our third problem is This is theoretical question only. Look here. A proton is moved against the Coulomb force of an electric field. Then see, first option is what? Work is done by the electric field. Second option is energy is used from some outside source. The strength of the field is decreased. The strength of the field is increased. Clearly you know that what is electric potential, the amount of energy is required to bring the charge from certain distance to in the electric field. So B option is right. Energy is used from some outside source. This is the question. Then come to next question. See, two negative charges. Clearly they have given two negative charges of equal magnitude are located in xy plane. As shown in the below figure. Also they have given the direction of the electric field at point P is. See, the next question is, they have taken xy plane. This is the x plane and this is the y. Here both are minus q. This is the minus q and this is the minus q. Here we want to find out the intensity of electric field. So what is the direction of the intensity of electric field? Always towards the negative charge, like this, due to this one. And one more is like this. Just you look the arrow mark in both the cases. Then resultant is acting like, this is like parallelogram law of addition of vectors also you are taking. So in this case the resultant is how much? Along negative x-axis. This is the resultant. Look this arrow mark. This is the along the negative x-axis. So generally we feel whenever they are giving figure and all this, we will confuse and we won't read also that question. So once you read, and you can sometimes know that questions are very easy also. Don't leave this type of questions. Then come to our next problem. See, this one also very easy problem based on the Gauss's law. They have given that the electric flux from a cube edge length is L and the electric flux is how much? Phi. So for confusion purpose they have given so much of matter like that, but the question is what? If the charge enclosed in the cube is doubled, then the electric flux is. So generally what is the formula for electric flux? You know that electric flux formula is phi E equals to 1 by epsilon naught times of the charge. 1 by epsilon naught times of the charge. Here phi E is directly proportional to charge. So phi E 1 by phi E 2 equals to, charge is increased twice means 2q we are taking instead of q cancel. Electric flux when charge is increased twice means 2 times of first one. Like that we can able to do this. So easy problem based on the Gauss's law they have given. Then we are going to the next problem. The question is, it is also very easy. Look here, concept based only they have given. Choose the incorrect statement. 14 September 2020 shift 1 they have given. Gauss's law, that is Gauss's law applies to a closed surface of any shape. You know that one of the limitation of that Gauss's law is it is applicable only for closed surface. It is correct only, but we want incorrect answer. Then second one is, according to Gauss's law, if a closed surface enclosed, no charge, electric field must vanish everywhere on the surface. Okay, that is wrong only. Why? Suppose outside you put one electric charge means intensity is acting. Intensity means we should calculate the force per unit strength, unit charge. So B is the not right answer. Then third one, you see Gauss's law can be derived from Coulomb's law. Yes, we can able to derive the Gauss's law from that. Then fourth one, according to Gauss's law, the net number of lines crossing any closed, that also giving the electric flux, that one. So this is our next question, very easy. Then come to next question. This is also, so this type of questions now we can save the time. Looking very big, but while doing these are no problem, easily when you know the concept, easily we can able to this. See this. In a uniformly charged sphere of total charge is how much? Q, and radius is R. The electric field E is plotted as a function of distance from the center of the sphere. The graph which would correspond to the above description will be, see, they have given four options are there and four types of graphs are there. So in this case, which is the correct one? They have given clearly that object is uniformly charged sphere. See, they have taken, this is uniformly charged sphere. We can take intensity is inside, then we are taking outside. So we should draw the graph. R is on x-axis and intensity on y-axis. So in this case, see, electric field due to uniformly charged non-conducting solid, for R is less than R and for R is greater than R, you can get different cases. If R is less than R, E is directly proportional to R. So it is like this, it is going like this. Then outside, if R is greater than R, means we should consider a point. This is R is here, sometimes this is on the surface, sometimes it is this. R is the capital R is the radius, small r is the distance. If R is less than R, this intensity is directly proportional to R. So you are getting the graph is like straight line passing through the origin. Then second condition, if R is greater than or equals to R, then what is that relation? That E is inversely proportional to R square. Inversely proportional to R square means we can get like this. Very, very important. I think many times they have repeated this question. Then come to our next question. It is also very easy. The question is, two small conducting balls of identical mass, how much? 20 grams, and identical charge also, 10 to the power of minus 10 coulombs, hang from non-conducting threads of length is how much? L equals to 300 centimeters. If the equilibrium separation of balls is, here they have given x is very, very less than L, then 4 pi epsilon naught value they have given, G they have given. What we have to find out? We should find out the distance between them. Here in this problem, they have given two balls are there. These are having the same charge. Okay, how much gap we are taking here? X by 2 plus x by 2, we are taking the x. They have given clearly this length is how much? L. From the Pythagoras theorem, from here to here, how much it is? Under root L square minus x square, x by 2 whole square. Then here tension is resolved into two components. One is T sin theta, another one is the T cos theta. And here mg cos theta, mg weight is balanced with T cos theta equals to how much? Mg. T cos theta equals to mg and T sin theta equals to f. From this, tan theta, sin theta by cos theta, tt cancel, tan theta equals to f by mg. But which force is acting between these two? Electric force is acting. We are taking 1 by 4 pi epsilon naught. This charge is q, this charge is q. We are taking q square by x square, as usual mg. From the figure, tan theta is opposite by adjacent. So x by 2 divided by under root L square minus x by 2 whole square. So instead of tan theta, we are taking this, instead of force, we are substituting q, 9 into 10 power 9 divided by x square into, this is the mass and this is the acceleration due to gravity. After simplification, we have to find out the distance between two charged particles. So x by 2 into this one, both the sides we are doing the cross multiplication and under root, then you are getting this value. Finally, our answer is how much? Our answer is, in this case, is 3 by 10 to the power of 1 by 3. 3 by 10 to the power of 1 by 3. So this is the method. This is somewhat lengthy but easy concept only. RHS side we are taking f by mg, and LHS side you should take the tan theta. Easily you can able to do this problem. Here this 10th problem. An infinite line of charge with uniform line charge density of charge 1 coulomb meter. coulomb per meter. That is the linear charge density. Placed along the y-axis, a charge of 1 coulomb is placed on the x-axis at a distance of how much? D equals to 3 meters from the origin. At what distance from the R? At what distance from the R? Origin, from the origin on the x-axis, we can get the total electric field is equals to 0. For this, what we are taking? See, one side intensity due to that linear charge density in terms of that one side we are taking that intensity. So linear charge density intensity is long straight conductor, what is the intensity? Lambda by 2 pi epsilon naught into R. Then this side we are taking 1 by 4 pi epsilon naught Q by, here R means we are taking that is the x minus R whole square. So they have given clearly that x value is how much? One side we are taking x means another side you are taking 3 minus x. See, lambda is 1 by 2 pi epsilon naught. We are taking this is the x. 1 by 4 pi epsilon naught. This value they have given 1. So total is how much? R minus x. 3. 3 minus x we are taking whole square. So after doing simplification, pi cancel, epsilon naught cancel, 2 cancel. So you can take this side 2 into 3 minus 2 into, this is how much? 9 plus x square minus 6x. It is equals to how much? 1. So after simplification you are getting x equals to 2 meters. You are getting x equals to 2 meters. Okay. Like that we can solve this one. Here you are getting that is 2x square minus 13. This side also you are getting 2 lambda by 2 pi epsilon naught. Here this side you are getting the 2, one more 2 is there. Then very simple question, look once. A negative charge is placed at the center of non-conducting sphere. The direction of electric field on any point, you know that for electric lines of force are diverging from positive charge, so outward. But for negative charge it is coming towards, this means what we are taking? Radially inward. So which option is right? First option is right.